this is Mrs. Bellotti. Today I am going to talk to you about your molecular geometry chart. I'm going to teach you guys how to use it. Now, I expect that you have already worked through your molecular geometry tutorial and that you've done the molecular geometry PhET simulation. Those two things need to happen before you watch this video. So go back and do that if you have not yet. But for the rest of you, let's go ahead and get started. Your molecular geometry chart is a useful tool. It looks like this. We're going to be giving it to you on your assessments, and you need to learn how to use this so that you can do your homework. We have to know the molecular shape of our covalent compounds. Now, this chart is useful. It is based on the valence shell electron pair repulsion theory, and it's necessary for you to be able to locate the central atom, locate bonding areas, and locate lone pairs. Okay, we're going to be calling these electron regions, pretty much areas where electrons are located. Now, there's one situation here where the chart won't help you. For instance, what if we have HCl? The first thing we have to do to use our chart is locate the central atom. There's no central atom. Well, in this situation, if there's no central atom, there's only one possible shape. What is it? A straight line, right? Linear. So this is the one shape situation that won't show up on your chart, but the rest of them will. Let's go ahead and take a look at our first line of our chart. The first line shows that when we have 2 electron regions and 0 lone pairs, that our shape is linear. So the example that I'm going to use today is carbon dioxide. So CO2, we see that carbon will form double bonds with oxygen. Oxygen, yes, has lone pairs, but only the central atom determines the shape. So for instance, you guys can see my shape here. I've got carbon in the center, my central atom. The 2 double bonds cause the 3 atoms to end up forming a linear shape. So looking at my central atom, carbon has 1 bonding area here, so 1 electron region there, and 1 electron region there. So consider in 3-dimensional space, if the electrons are going to push away from each other as far as possible, yes, we'll see that this is 180 degrees. So perfectly straight line. The second line, it's not as common. So there are situations where there's 3 electron regions. We will not see it as frequently in chemistry, but it happens. My example to show you, let's go ahead and do formaldehyde. So formaldehyde, CH2O, carbon is the central atom. It actually forms a double bond with oxygen and then 2 single bonds with hydrogen. So carbon is our central atom. I don't know if you guys can see it. Okay, has that double bond. So the first thing we need to do is identify electron regions. We've got 1 bond, 2, and 3. So we've got 3 electron regions with no lone pairs. So you guys can see that it's a perfectly flat plane. Do you guys see that? So we call it trigonal planar. Now there are going to be situations where you may have a third area that's a lone pair and that your molecule may end up being bent. So you need to look for that molecular geometry as well. Let's go ahead and look at line 3. This is more common. We're going to see these molecules in chemistry more frequently. This is when we have 4 electron regions. So let's go ahead and start with CH4. CH4 is methane. We will see that carbon has 4 electron regions. These all happen to be bonds. So we have 0 lone pairs on my carbon. Therefore, this has to be tetrahedral. So my tetrahedral shape is right here. So you can see that these angles, they're not 90-degree angles. They push as far apart as possible in three-dimensional space. So they'll end up being about 109 degrees away from each other. So this is a tetrahedral molecule. Now, what if there's 4 electron regions, but one of them is a lone pair? So imagine if I take my tetrahedral and I remove one of the bonds. Well, right now, I still have a lone pair of electrons up here, and I've got 3 bonds. So I still have my 4 electron regions, but now the lone pair up here, you have to imagine it, it is pushing those bonds away. So I don't know if you guys can see this. So because it pushes it away, it forms a pyramid shape. So this is called trigonal pyramidal. My example for that, we'll go ahead and use a different color. We'll go ahead and use NH3. So nitrogen has 5 valence electrons. It ends up forming 3 bonds with hydrogen. But this lone pair of electrons, their electrons, it's an electron region, is going to push all of the bonds away so that it ends up being trigonal pyramidal. Now, this one's my favorite. You guys have all seen this molecule before. Let's say I remove another bond from my original tetrahedral. What does this look like? Every single one of your chemistry teachers has drawn this molecule so far. Did you guys say it? I hope. Water, right? H2O. Oops. All right, H2O. I've got my oxygen. It's bonded to 2 hydrogens, and there's 2 lone pairs. So let's take a look. It has 1, 2, 3, 4 electron regions. It's got 2 lone pairs, so that the shape is going to be bent, which you guys can see. I've got 2 examples here. That one's my favorite because you can work in reverse. If you think about it, if you just have 2 atoms, you start with linear. This is just working around the tetrahedral model. If I add 1 bond and I've got 2 lone pairs, it's bent. If I add another bond, I only have 1 lone pair left. It's trigonal pyramidal. And then finally, if I put all 4 bonds back, I have my original tetrahedral. Now, we get a little bit more complicated. You'll see that the 4th and 5th lines of the chart, we've got some strange shapes. Trigonal bipyramidal, octahedral, seesaw, square planar. The shapes are not endless, but there's a lot. Right now, for chemistry, what I need you guys to know is how to use the chart, but also the most common shapes I've highlighted. Those are ones that we expect you guys to be able to identify quickly. And hopefully this chart will help you guys when you're learning to do this. All right, feel free to reach out with any questions you have to your teacher, and I hope this helps.